Hello, good evening. Thank you for coming. It's a big pleasure today to present you Ricardo Vladimiro, which is coming to present us about data analytics in the realm of video games. He has a very interesting career, which he will surely tell you about. And so without further ado, Ricardo.
Hello, it's working. Yeah, it's working. Well, hi, hello. My name is Ricardo Vladimiro. I'm going to present myself in a very embarrassing way. I am the Game Analytics and Data Science lead at Miniclip. I worked in IT engineering since 1993 until 2007, and since then I've been working in game development. I've done pretty much everything as far as it goes to game development, with the exception of graphics. I've coded, I've produced, I've designed, I did music, I did sound, and now I do data science and game analytics. In my part-time, I am Batman's arch enemy, which is my colleague, Marcelo Carriaga, and the only reason that I'm doing this is because I did a bet with him, and I'm going to embarrass him in public. Today we are going to talk about game analytics, and what I'm going to do, I'm going to go through this agenda really fast, because what I want is to give you the baseline so that you can then ask me anything you want regarding games, analytics, data science, wherever you guys want, okay? So I'll try to go really fast about Miniclip, in case you don't know it, and more specifically the BI team and what we do there, key concepts about the types of analytics, also a little bit of what is data science, because it's kind of fuzzy right now what data science is, and then I'm going to finish with 3 real-life examples of things that we do at Miniclip, and then we'll have the rest of the time for questions and answers, okay? So, starting with the beginning, Miniclip it exists for about 15 years now, 6 here in Portugal. We have 4 offices. In Switzerland, we have the headquarters. In UK, we have the web team. We have the marketing team, the advertising team. In Portugal and in Italy, we have mobile teams. The biggest studio is here in Portugal. Of the almost 200 people that Miniclip has, around 120 are now in Portugal, and we expect to have at least 60 more until the end of the year. The biggest studio is here, and the reason for this is that we do the biggest mobile games here in Portugal. So in Portugal we do the 2D mobile games. Our biggest game is 8-Ball Pool, which that's not false advertising. It is the world's biggest online pool game. You probably heard about this one, IADE-U, that appeared some weeks ago in the Netflix series House of Cards, and it won this year. It won the best mobile multiplayer game of the year. 2 years ago, when it was the World Cup, we released Soccer Stars, which is basically like a flickering game to play football, and we have released a couple of weeks ago, Basketball Stars, and we also publish, we did not develop, we just publish Bowling King. We have a lot more games, a lot more games, but these right now are the biggest games that we are working. Within Miniclip, there is a very special department. It's called the Business Intelligence. It exists for about 2 years now, year and something, and it has 3 teams in it. It has the Business Analysis team, which is made of 2 people, and we are hiring 1 more in UK. What they do is basically analytics and analysis on a higher level, so on a company-wide level. They take care of everything that is related with everything that the executive team needs, things that are related with marketing and things like that. We have another team, this one here in Portugal, with 2 people, hiring 1 more, which is the data engineering team. They are my best friends. So everything that I'm going to show you is only possible because we have these fantastic people doing all the big data stuff. So they take care of getting all the events and taking care of these clusters with huge amounts of data. So that's and maybe I'm biased, but the cutest team at Miniclip, which is the Game Analytics and Data Science team, which is the team that I lead. There's 4 of us there. And what we do is, basically, we take care of business intelligence systems. These are clusters of data. These are APIs that receive events. These are connections to things outside. We also manage products from third parties. For instance, we manage our services in Google Analytics or in a service called IADE-U, which is also a third party, and BIME and a couple more. To these services, our products, meaning our games, and our website, which is also made of games, sends data to either us or these third-party softwares and services. Okay? And then we get data from even more people, from social media, from ad networks. We have dozens of ad networks working with us from the app stores. And we put all of this into these systems. The central repository is called Cerebro, which is really cool, right? So the place where we have these large amounts of data is Cerebro. And by having those systems, we can then do things like dashboards for the whole company to use. Everyone, with the exception of the IT team, has got some thing in dashboards that we did. We also do analysis. For instance, if someone asks us a question, my team will answer that question with a statistical analysis. We do experiments, which you probably heard of as A/B tests. We do a little bit better than that, and I'll show you in a bit what I mean by that. And then we do data products. If you heard of machine learning and things like that, this is what I mean by data products. We will also explore this later on. To give you an idea of what those 8 people, soon 10, I hope, do on a daily basis, we collect more than 1 billion events. The presentation that I did, where I wrote this for the first time, was in September, and I was lying. It was already more than 1 billion events. The truth is, right now, I really don't know how many events we are collecting, but it's way more than 1 billion per day. Okay? Maybe it's 2 billion. And we do this, the events that we collect are from interactions that 22 million daily active users have on our website and on our games. So this is more than twice the population of Portugal, daily. And from those users and from all our systems, we do per day around 425,000 predictions. Okay, so this is just to give you a quick scope of what we do in the business intelligence team and the teams that we work. And now we are going to discuss analytics. Not game analytics, we are going to check game analytics a little bit later. Now we are going to discuss analytics as a whole. Okay, what does this mean? So I went to this place. I heard that there's information there. So, and I got, this is the first sentence that is there. There's that analytics is the discovery, interpretation, and communication of meaningful patterns in data. This is what analytics are, but it is not exactly what we do with analytics, right? So I read a couple more paragraphs, and a little bit lower than that, we had this sentence. Firms may apply, they may not, but they may apply analytics to describe, predict, and improve business performance. And the reason why I use those colors there is because these are the verbs that matter as far as analytics go. So what they do is they describe, and what describe means is that we are describing the past. Okay? Even if I have real-time analytics, even if I have a dashboard that gives me, like, at this second, what's going on, when I see it, it's actually already past, right? So we are always describing the past. Okay? The other thing that it does is it will predict the future. Given what we know right now, we can predict what is going to happen. Okay? And last but not least, we can improve. And the trick here is that we improve continuously. We can think that it improves the present, but that's not actually true. It improves over time. It keeps improving. Okay? And these are the 3 types of analytics. The descriptive analytics, which just describe the past, the predictive, which predict the future, and the prescriptive, which improve continuously. And it's easier when you have examples. So, let's imagine that you pick a newspaper and you see a pie chart there, any pie chart or a bar chart or any other thing, and you look at it and you see that graphic, right? That's descriptive analytics, right there. When you go into a spreadsheet and you create, you are in fact doing descriptive analytics. Okay? When we have a sales forecast, we have predictive analytics. So we know how many sales we had until now, and we predict how many sales we expect to have in the future. So what is the expected value in the future for something? In that case, we are predictive. The prescriptive is the really cool stuff that is going on right now. In each one of your phones, in each one of your computers, prescriptive analytics is happening. And these are things like product recommendation. For instance, the thing that started all this and that brought a lot of attention was Amazon. When you go to Amazon and you want to buy a book, it's going to give you a bunch of other books, right? That is a product recommendation. That is looking at what you browsed, what you saw, what your friends saw, what people that saw that also bought, and then it creates a group of products that is going to recommend you for you to buy. That process is fully automated. There's not a human being on the other side looking at what you're browsing and saying, I'm going to put this book. That doesn't happen, okay? As you probably suspect. So the differences between these are, well, there's no difference here. Regarding discovery of those patterns and the treatment of that data, there's really no difference there, right? It's impossible nowadays to do this by hand. Anything that has got more than 15 rows of data in a spreadsheet is already an headache when we are talking about billions of events and millions of persons interacting with apps. That's not going to happen. So in all kinds of analytics, everything regarding the discovery and treatment is computational. Okay? When things start to change, it's interpretation. So for instance, when you have that newspaper with that pie chart, there's no interpretation there, right? You're doing the interpretation. You're looking at it and seeing that one bar is bigger than the other. You are interpreting. There's nothing, it's all you, right? It's just a graphic there. When we go to predictive analytics, actually, the interpretation part is computational. So we start to have things like, for instance, a system in the sales forecast will say that we expect this to happen, but we have like this margin of error. Okay? So it gives us a little bit more of information, but it's interpreted always on the computer side. It's served to you. And in the prescriptive analytics is obviously computational, so everything is done by the computer systems. And last but not least, the communication, and more important, the decision. When it comes to this, if there's a decision, it's human, right? It's a person that will interpret and say what's going to happen, correct? In the predictive analytics, it's also human. So we have a system in front of us, and we are going to make a decision given the information that's been given to us, predicted by the system. In the prescriptive analytics, it's also computational. In the case of the product recommendation, it's the algorithm that will define what it is that you are going to see. There's no human interaction there. Okay? All good? Right. Okay. Let's go to data science, the fuzzy part. And let's go to my favorite site ever, Quora. I had a difficult time. I have this big block of text that I use when I try to explain to someone written what data science is, because right now it's really, really confusing what data science is. But Quora has got a very pretty interpretation. The scientific approach to knowledge and extraction from data. And this is true, but like with the analytics part, this is telling us what it is, it's not telling us what it does. So I'll try to explain exactly what it does. In practice, what we have is a large pile of data. Okay? And then we apply to that data a large amount of knowledge. This is the kind of stuff that usually people that work in data science know. Now, usually people think that every data scientist knows everything about this. Usually what happens is that data scientists are specialized in 2 or 3 areas, and it's a teamwork. Okay? But we pick the data and we apply knowledge to it, and the output of that is a data product. Okay? And the data products are things like recommendation engines, things like fraud detection, things like churn detection. So they are products that will somehow interact with the data in a way that it would not be possible for a standard system. So if we have a web page that is connected to a database, that is pretty much traditional, right? We just need to connect to the data and display it. But when we have to model, when we have to predict, when we have to measure, when we have to do A/B tests on the run, sometimes we do A/B tests with thousands of variants happening at the same time. All of those things need to be automated, and the automation is only possible given this knowledge and the data that we have. And that creates the data product. To me, in my interpretation, this is mine. Right now, I tell it's really confusing, but my interpretation is that data science produces data products that would not be possible to be done by traditional means. This is my interpretation of the output of data science. And how does data science does it? Probably something that you have seen or not, yeah. So we always have a question. For instance, can we, and let's picture this. Let's imagine that you have a game, and you know that sooner or later the players of your game are going to leave the game. So your question is, can I prevent somehow the players from leaving my game? That is a question. And then we do some research. We try to understand what are the behaviors of the players, and we start to build our data sets, and then we build an hypothesis. And the hypothesis is that the players are leaving for this reason, so we should affect this somehow. And then we run the test and do the analysis. We draw conclusions. The conclusions creates more data. The data creates more questions. This is basically a circular, simplified scientific method. Right? What happens is that we have constantly questions that lead to hypotheses and tests, and the feedback that we get from those tests and the conclusions that we reach will give us more questions, and so on and so forth. This is a never-ending loop of questions and tests. Which leads us to game analytics. And now, yes, game analytics, I'm going to show you examples of the three things. So, descriptive, predictive, and prescriptive analytics. The first one is really easy. This is descriptive analytics. This is one of the dashboards that we have at Miniclip. This basically tells us how many users did we get on mobile coming from the website. It is very informative. Basically, we can see from the sizes of the boxes in the tree map what are the games that mostly benefit from these events. We know how many of them happen over time. But this is purely descriptive. We can think that maybe we need to improve something, but we cannot really act. We can just know. It's just describing to us, right? So you will see things like this over and over and over again, everywhere. Everything that gives you information that you can quickly consume is descriptive. Okay? It doesn't mean that you can make a decision or act on it. The second part, this was the first data product. So this is, to me, data science. This was the first data product that I coded at Miniclip. This version is a big improvement. Mine was much uglier. This was one of my team members that improved all this. This is a data product called Libra, and the reason why I put this here, it's not the easiest one to explain, but it does take us to a lot of different aspects of the predictive part. So Libra is a randomized controlled trial platform. What Libra does is, first, in Cerebro, remember Cerebro? We have this amount of data in Cerebro, and we know a lot of things about groups of users, about segments of users. So all of that data is aggregated and is made available to this application. When we want to start a new trial, which we can call a new A/B test, it's going to query the database and determine the variables that it needs to know what are the sizes of the groups, depending on the statistics that we chose to create our groups. So before the test even starts, there's already a large amount of data engineering involved in having all of that data available, both internally and also to the application. After we create this, we say that we want one test group. In this case, it's B. I don't know if you see it very well, and it's going to give us all the variables that we need to know, and we create a trial. As soon as we create a trial, there's going to be a API channel open from where our games can ask then what group am I, and then we are running literally an A/B test. As the players are using the application and they are seeing different versions of the application while we are doing the A/B test, we are collecting data from the behavior of those players, and we start to establish in a very scientific way if something changed, literally if our experiment and the hypothesis is a good one or not. Okay. In the end, what this does is that we just close. And why is this predictive? Because in the end, we create a report that we take to the stakeholders and say, so this is what we found. These are the differences between from the player behavior from one group to the other. Okay. And they will make a decision. Therefore, it is predictive. If this system analyzed the data and automatically defined what was the winning group, it would be prescriptive. Okay? A/B testing is a big part of video games publishing nowadays. Pretty much all of the big publishers on mobile and on web and also in the consoles have got very large analytic systems that run A/B tests all the time, many times multivariate. So this is a very important part in terms of video game industry right now. The last one that I want to show you is technically the coolest. Unfortunately, it's all code, so I can only show you boxes with arrows. So churn detection. What is churn? If a player leaves a game, we say that the player churned. Okay. We need to define exactly what is a churn player, so a player that we believe is not going to return. Okay. What we want to do is to prevent that user leaves the game. Okay. So the way that we do this, we created a data product where we fit a model. I'm going to explain what fitting a model is. We have this new group of users. And those users arrive to the game and then we wait 7 days. Why 7 days? We want to predict if the player is going to leave after the first 24 hours of game. We call this the day zero churn. So if I play the game for the first time today, I want to know if I'm not going to return ever after that day zero. Okay? So we wait 7 days, and the reason why we wait 7 days is because we want to be sure that the players that we are going to mark as churn are really not returning. So we wait for 7 days and we make this question, did we see each one of these players again after that day zero? And if we have seen them, so if they play the game again, they are going to be labeled as non-churn. So the players kept playing the game. If, on the other hand, they never returned after day zero, we are going to label them as churned. Okay? These are very simply just labels, like a churn yes or no, true or false. Okay? What we then do is we pick the data only from day zero with the labels, and we create a churn prediction model. Think of this as a black box where I can put new information in and get new labels out. Okay? So now I have a model of the player behavior. I can say at this point in time with 85% accuracy that a player is going to leave the game or not after the first 24 hours that he played. Okay? So now that we have that model, what we do is we pick the new players that enter the game after, in the next days, and after 24 hours we are going to pick the day zero data, we are going to pass it to that black box, to that model, and the model is going to look at the data and it's going to say, did the player churn? If he didn't churn, if he doesn't believe that the player is going to churn, he's going to label him as non-churned. If, on the other hand, with that day zero data, the player in fact did churn, the player in fact is labeled as churn, then what we do is we take action and measure. We need to measure all the time. So what we would do in the case of an A/B test was we would make this prediction for new players. Some players would get that label saying churn. And then what we would do, we would divide the players and we would do something, send a push notification, offer them something for them to return in the game, something like that. And then we would measure if there was a difference that was measurable and significant between the two groups, the group where we did nothing, but that was labeled as churned, and the group that was also labeled as churned, but we took some action. Okay? And then we collect this data, we analyze, and then this creates more questions. For instance, was this effective? Did this have an impact in the economy? Did the players in fact return? Was there any problem? And so on and so forth. This is a fully automated prescriptive analytics data model with a machine learning algorithm that, I don't know if you guys like machine learning, if you like and heard of random forest, this is the algorithm that we use. And this is pretty much how all of these products that are fully automated, like recommendation engines and so on, work. We create a model from the data that we already have, and then there's a model that learns from that data, and given that model is created, the system has learned the behavior, and then we can inject new data with new behavior, and it's going to tell us what is the expected value in the future. Okay? So I went through this really fast. It was on purpose, because I want to hear from you. I want, first and foremost, thank you very much for inviting me, and thank you all for coming here. I am at, you can ask me whatever you want from this moment on. So, questions?
So thank you. I just ask anybody that wants to ask a question to request the microphone and then to identify themselves before asking the question.
Hello,
Hi.
João Martins. I wanted to ask in that prescriptive,
Sorry?
in the prescriptive analytics,
Yes.
I wanted to ask what kind of measures can be done if a player is, as it said, churn.
That is a complex question. So usually, and if you look for things like churn detection, you will find that some companies have exposed and told their story about how they did it. And usually what mobile companies do is they will send push notifications. The reason for that is that there is an expectation that if the push notification has got the right message, at least the player will return to the game. There are other things that can be done, but it depends a lot on the medium. There are other tools like contacting the player on Facebook if he was connected to the game on Facebook. It is possible to have friends inviting him to play and things like that. As far as game analytics goes, and for instance what my team does, we don't actually decide what are the campaigns or what are the channels that will engage with the player. Our objective, we have two objectives. The first one is to create a model that has a very high accuracy, so that we know that if we are labeling a player as churn, that in fact it did churn, or if we label him with anything else, that it is a good model. And then whatever is the decision that is going to be done in terms of interacting with the player, that we measure so that we understand if in fact it was efficient and if it was worth to do, or even sometimes we just have more questions. That's the honest truth. I think that most of the time people think that machine learning is like, oh yeah, we just create a model and it's working. That doesn't happen. So what happens many times is that we just have another question. Sometimes we run A/B tests, and again we look at the A/B tests and we say, oh, wait a minute, why did this happen? And we go back and we have to rethink. For instance, at Miniclip, we have this very important thing, is that nothing is more important to us than the players like our game. Okay, so the first measure that we have is retention. Do the players return to the game? We are not really worried about increasing revenue if players are leaving the game. So if we have an A/B test, or we do some product where we see, for instance, that revenue increased, but we have like this drop in retention, we are like, what happened? Why are we losing players? So many times we have like these circular things where we have to continue to make questions and continue to analyze and so on.
Thank you.
Yeah.
Hello,
Hi.
João Serpa. You said 85%
Yes.
was what you have now.
It's the accuracy rate of the churn prediction model.
Okay. Do you think you can improve that? Is that important for the company, or is that? I mean, they are asking you all the time. Hey, no, it's not.
No, it is important, but it's an internal metric.
Okay.
So I don't think. Well, we are asked, but we are asked more out of curiosity. It's really our measure. If you ask me, the question is really good. The question, if I understood correctly, what you want to know is.
It's good. It's good.
Are you happy with that? Do you want to improve it? Right?
Yeah. You're the boss.
It depends on the model. For instance, we have accuracy. In machine learning, accuracy is not really the best way to describe a model. There are other things to consider, like sensitivity and things like that. For instance, we have a model that predicts fraudulent behavior in one of our games. So we pick behavior from the users, and we can predict if the users are doing things in the game that we shouldn't. Okay? In that specific model, I really don't care about the accuracy as long as the false positives are 0. I cannot act on a player assuming that he has got a fraudulent behavior if in fact I am not 100% sure that he is. What happens, obviously, is that we don't pick all of them. But on the other hand, we are not going after players that really aren't doing anything bad. So it depends on the application. For retention, 85% is pretty good because I want to affect as many players as I can, right? But for fraud detection, it's really not the 85% or the 70%. As long as I can be as high as possible without having false positives, I'm happy. Do we want to improve? Always.
Hello, my name is Fabio Costa. I'd like to ask what kind of information do you feed the machine, I guess, when you have a new player and it churns? What kind of information do you have about the player to relate it to future players, since he's a new player and you don't have any previous information about him?
Okay. I have exactly the same information that I had to build the model. So if you notice, let me go back just a bit. I said here. So when I create the model, although we wait for 7 days, because we want to be sure that those players actually didn't return to the game, the data that I feed is just day 0 data. If you ask me what data is this, is like how many games did he play, the session length, how many sessions did he have, did he make purchases, things like that. But I pick the day 0 data. Although I have potentially 7 days of data, I only pick the day 0 data. Then I feed it to the model. Later on, when the model is already built, what I do is I feed the day 0 data. So it's exactly the same data. Okay? Does this answer your question?
Sure. It was more about the player profile itself. Because to me they are just players.
Yeah.
When we are seeing, it's an object, like an object, but what would relate the player in the sense of person to distinguish from another player with the same aspects that would also live?
Okay. Their behavior. So, and by behavior I mean the things like how many games did he play? These are multiplayer games, by the way, so there's a lot of things like the percentage of times that he won the game. Was the last game a defeat? Actually, in the churn model, this is not included. But that kind of user behavior, the interaction with the game, basically that's what makes people different in the game, right? For instance, amazingly or not, a long time ago, I don't know, 3 years, something like that, we had this thing in the game where we saw that people were for hours in the game, but they didn't play. And we were thinking, why? The purpose of having a game open is to actually play the game. So there was a counter where they could win coins. So they just had the game open. So blink, they clicked, got the coins, and then it just reset. You know? So they had the app open just to get the coins. They weren't really engaged in the game, right? They were retained because they had the app open. But that, if you compare the behavior to the people that only played for 10 minutes but played 2 games, it's completely different, right? The people that were doing that weren't really interacting. If you pick, the whole beauty of the game analytics is that you actually are looking at, you understand people behavior. There's nothing more amazing to me than the players of our games. What they do, the way that they interact with our games, to me is absolutely amazing. And it's incredible. And it is true that we have millions of daily active users, and this helps a lot because it's much easier to build a model with millions of users than to build with 100. I guess it's not possible because something like half a second of a difference in the average session is relevant. It can be relevant. So all of those things are important to create models and to do analytics even descriptive.
Thank you. I have another question, if I can. In that, after what you said, what would you say would be the better indicator about player having fun in a game?
Of the player?
Of the player having fun. For example, you could say it would be the duration of playtime, but in some cases it's not the best.
I don't like it.
Maybe returning every day, something like that.
Well, in my opinion, it depends on the game. I've wrote, actually I should have an image. I have an image on my blog which pretty much defines the blog. It's also the header on my Twitter and things like that, which is something that I built called the player life cycle. The player life cycle is the player starts a game. I describe this like a love story between the player and the game. It's like in the beginning it's like very fun, and then time goes on and it's not working for me, you know. It's not you, it's me kind of thing. Over all the steps, the acquisition, the retention, the engagement, the monetization, the virality, and then churning and leaving the game, all of those steps are relevant. The one that industry-wise it's more looked at is retention, because retention is kind of cold and it's very easy to understand. To me, it's engagement. The problem is that engagement is retention day one is my favorite metric ever, okay? But in terms of analyzing fun, engagement is really important. And to me, what defines engagement, people look at engagement as number of sessions per day, time per session, and so on. I don't think that shows anything. To me, it's the meaningful interactions with the game. So, if you are playing pool, your meaningful interaction with the game is playing pool, okay? Going into a table and playing it against another player, you know? If players stop doing this, the main action of the game, trust me, they are not having fun. They are just there because reasons, you know? If it's a driving game, what defines if they are having fun or not is how many times are they doing that, okay? Is there a decay in the number of times that they are doing that? I swear to you, they are literally like losing all the fun of the game. Because that happens and we notice that. Okay? So to me, fun is defined very mathematically and analytically as the number of meaningful interactions with the game, and that depends on the game.
Okay, thank you.
Hello, I'm João Antunes. My question is, why is only the first day important? Can't you have like 2 different players that have the similar day 0 data, but then in the next 6 days, one actually uninstalls the game and the other is addicted?
Before I drove here, our head of design made exactly the same question. And here's how weird it was. He asked about day 6 like you did. True story. So he was on my Skype and saying, why day 0? Well, quite honestly, because the reason why we did day 0, it was a proof of concept early on, and the day 0 is the day where most people go away. Okay? Historically, for mobile games, the day zero churn or the day one retention is like when we lose half of the people easily. So if we can act on that half of the people, we probably can have a big impact. Think of this in terms of percentage. If you lose 50% of your users and you can act and get 10% of those 50%, it's much more than after 6 days where you have a much smaller number of users. Okay? So to us, when we did initially the model, it was really a proof of concept. We wanted a lot of data because we really didn't know how that was going to work out. And to have a lot of data, day zero is like perfect. However, right now, we are working and we are thinking about other ways for a number of reasons. Some of them I cannot really discuss here, but there are things like, for instance, day 7 is pretty relevant because day 7, if you look at data from games, you will see like this weekly trend. For instance, people that start playing on Sundays usually return less to the game. But on the other hand, we have a large number of players on Sundays because it's weekend, right? And football game is over and they are going to play something. So we have these wavy lines with weekly, so with weekly trends, which means that to us, looking at day 7 is logical in a way, because we can even use the day of the week as a way to further have a better model. Okay? That is really the only reason. The problem with churn, and also with other things, for instance, I spoke about fraud detection. Fraud detection is really zero in on that problem, right? Churn is a lot of things. People that stop playing after a year, we have people playing 8-ball pool for 2 years now, like almost daily. If one of those players stops playing, it's for a completely different reason of someone that stopped playing in the second day, right? So churn is a very complex problem. It happens for a various number of reasons. We pretty much need to have a model for each of the problems that we want to affect. And honestly, day zero, a lot more data for the proof of concept. That was the starting point.
Thank you.
You told us about churn prediction and fraud prediction.
Yeah.
Can you tell about some more models?
Some
more models, if
yes.
there are any more?
So we are working on a lifetime value model. So this is something like quick concept. When we talk about cohorts of users, we are basically talking about a segment of users that started to play on the same day. Okay? And then we have retention days. So if I started to play today is my day 0, tomorrow is my day 1, my day 2, and so on. Okay? We want to be able to predict what it's the value of a group of users that started of a cohort of users that started to play on any given day, from any given marketing channel or from some country, and then we want to predict in a very short amount of time, like a week, how much money do we expect to do per user after a year. For instance, that is relevant for a number of things, marketing being the most obvious. We are working on that. We have some initiatives that are more technical, like segment users, things to do clustering analysis, so to automatically create clusters of users that have something in common. If I'm not mistaken, the Netflix product recommendation has got something to do with clusters, so basically they cluster the movies that have got like the same rating, and then they will show you movies from that cluster to you because you like one of the movies there, things like that. We have a cool one. Yeah, I'm going to talk about it. We have a very cool one, which is to, I don't know how this is going to work out, but it's so science fiction. You're going to love this. It's so science fiction that I want to predict if a user is going to have a certain event. Okay? So, is the user going to, for instance, play on a higher level? Things like that. This is more a techie proof of concept kind of thing. I don't even think that it has like a proper use that I can think but we are definitely trying to do product recommendation. For instance, if a user in Soccer Stars buys Barcelona, does he want to buy Real Madrid? Maybe not, but maybe he wants to buy Manchester United. So things like that. There's a lot of things going on. But the big projects are really churn, fraud, and lifetime value.
Thank you.
That was my question.
Okay. Okay.
So maybe I can ask a question also. How much of what you do is actually for prescription rather than description or prediction?
Yeah, the vast amount of things that we do is for prediction. So we do a lot of randomized controlled trials. That takes a lot of work. We do a lot of experiments. In the beginning, we did a lot of descriptive, but the truth is, when you don't have dashboards and things like that, you will end up using a lot of your time to build those dashboards. But after those dashboards are done, it's more like maintenance or a new game that we have. I think that this ends up being a path, you know? When I started to do this at Miniclip, we didn't have any dashboards. So to build all those dashboards, it was long hours just building dashboards after dashboards after dashboards, and then the team grew, but the number of products grew, and then it was more dashboards and dashboards. As soon as we started to take dashboards out of the way, what ended up happening was that we were already doing A/B tests, but in a way they were really simple A/B tests. When we started to want to do more serious A/B tests, then we had to improve quite a bit in everything: the analysis, the definition of the test, and so on. And for a long time, that took quite a bit of time. Now it's almost automatic. The discussion, the preparation, running the tests, running the analysis, presenting every decision, these things are pretty much rolling right now. So we are investing a lot more in prescriptive products. So I think that it is really a path, something that you go through. It's like an adventure, you know. It starts like really complicated and I don't know what I'm doing. And at some point in time, you're giving talks talking about churn prediction models, you know. So I think right now, a lot of what we do is definitely prediction. We are improving the randomized control trial tool quite a lot, but we are also looking forward to interact directly with the games with the prescription product.
My name is Pavel. Hello.
Hello.
The question is, having so many players, probably you have some throughput problem when many users try to send data to your servers. So what kind of technology at Miniclip is used to transport data from users to your system which receives that data? Can you explain in brief what is used to solve this?
I would love to, but I really don't know. So in terms of technology, I can tell you that we are using Amazon Web Services for everything. I don't know what is our API. We have Cerebro, and it's the third time that I say Cerebro because it's a really cool name. We have got an API that receives all the events. The API is called Goliath. We have this API that gets all of the events. I don't know how it was built. There was a number of discussions, but it's really a data engineering problem, and I don't know exactly how it was solved. But I know that it's fully built on top of Amazon Web Services. I don't really know if it's Kinesis at this point in time. It might be Kinesis, but I'm not going to say that it is because maybe it may not be. It's not really my realm. Unlike statistics, it's the data engineering that did all of that stuff.
So Kinesis serves for this purpose, right?
Sorry?
Kinesis can pick up this task and solve it, right? I mean, in your opinion.
I don't know. You can do a lot of data engineering questions, but I really don't know. What I do know is that in terms of structure, what we have this API. The API receives the data. It goes into buckets, and then those buckets are treated and then loaded into Redshift. Okay. The process that goes from the API to the buckets, I really don't know how it's done. I know that it was stress test, and that right now it takes 8-ball-pool fully, like everything from 8-ball-pool goes into there. And if it takes 8-ball-pool, it can take anything really, because 8-ball-pool is huge and we have a lot of players there. But it can grow even. So I don't know if it's elastic, for instance. I really don't know. It's beyond my control.
Thank you.
Yeah, well.
Any more questions? Well, if there are no more questions, I would like to thank Ricardo for this wonderful talk.